So I'm calling this section list comprehension part 2, and the reason why is that list comprehension part 1 got relatively large, so we're kind of like moving on to the next one. But in list comprehension number 1, we were able to we created this list of names, so we were working with strings, and then we were able to do something like something that was relatively complicated, i.e. extracting names from this list where the names contain the letter E and the letter I, and we showed it with a classical for loop, so our old method, and then we showed how we could achieve the same with a list comprehension in a faster way. And in fact, one thing to note is that over here we could even have an extra bit where, like, if we wanted to find the names with so we found the names with E and with I using both methods. So let me just run that. There's the names with I and E in it, Charlie and Alice, and this was method 1, which was the classical method. So this was method 1, and then method 2 was the list comprehension method just down below. But let's say, for example, we wanted to do something else and also like get Elsa in there, something with the that had a capital E. Well, in the list comprehension, so an E and an I, but then also like an or, so an or and E. So we can just do this in list comprehension relatively straightforward like this, or quotation E in name, and E, let's put that right, in name. So we could do this relatively fast in the list comprehension method, and when we run it we just see we get Elsa down at the bottom. If we wanted to do the same in the classical old method, and again this is just one of the wins of doing this, is we need really to construct another if statement here. So if E in name, then again we would want to do name with E dot append name. Now you can kind of like see where this list comprehension, and we could have this also all on one line, where this list comprehension has got an advantage. I'm just going to hit run here just to show both do achieve the same output. So list comprehension, we discussed before, like in certain cases, but in particular where we're creating a new list and appending the name to the list comprehension is actually faster than the classical for loop. So we prefer the list comprehension method. We're just going to do in part 2 now, so we're going to move over. We're going to do list comprehensions, but this time with numbers, because we want to do like more operations. We could do it with a string here, like, so we could do something like add a second name to each name, maybe, but anyway, we'd probably have to like it'd be quite messy doing it over here. So let's just do it again, and actually let's put in numbers anyway for the sake of having something slightly different. And the first thing that I think I'll do is something like we'll just do numbers is equal to, and then we'll just create our list. So let's make just a list of random numbers, 10, 20. We'll make smaller numbers because maybe we'll just go along and square them or something like that. So 1, 3, 6. There's no particular order in here. By the way, we're going to do things like random numbers as well and other things in later sections. We've not got to it yet, so I'm randomizing. I'll increase them in size for the sake of doing that, but we won't do more than that. 10 and 12, and then maybe like 20. There we go. So something like that. Should we? I'm just wondering if we should put an outlier. Maybe not. So again, we'll have our classical method. So this is our classical for loop over here, and then we will have our list comprehension, which will be by way of comparison. So we're going to compare the two methods basically, and let's say we just want to square all of the numbers. So our task is we want to square all of the numbers. We want to find the squares of all of the numbers. So what we want to get back is something like 1 squared is 1, then 3 squared is 9, 6 squared is 36, 10 squared is 100, 12 squared is 144, and 20 squared is 400, I believe. It's 20 times 20, which is 400, yeah. Okay, so we go into our classical for loop, and again, we're going to need to do something like square numbers. So we're going to need to create a empty list in order to populate the list with our square numbers, and we are going to have to do something like the for loop. So for n or number in numbers, whatever we want to choose. Let's do number. Let's do for n in numbers. This time we'll change it up for n in numbers, and then we can do something quite simply like square numbers dot append, and then we're going to append it by n squared. So we can do n squared in Python is like that, which is these 2 times signs. That means to raise a number to the power by, and we could finally we can print square numbers just like that, and we get our square numbers. And actually, let's print our original list as well. We just print out numbers like this. I think it'd be easier. So print numbers. So we've got our numbers, and then we've got the squares of the numbers, and my maths works, so I'm quite pleased with that. But again, we can do this list comprehension. We see this thing here where we are creating a empty list, and then we are appending to the list, and that creation of empty list and appending to the empty list is telling us to that we've got the potential to do a nice convenient list comprehension. So let's just do that, and we will just say again, we'll just say that square numbers. So we're going to overwrite our old square numbers with this new one, but this time here's our list creation. We've already done it. So we've done this line, line number 8. We've done it over here at line number 15. They look completely identical at this point in time. I might actually get the pens out to draw that. This line and this line are completely identical right now. And all we're going to do is extract this part out of here and stick it into our list. But we want to get, and if we remember from the previous video, we also want to get this bit here to go into the list, sort of like at the beginning, n squared. So that's what we're going to try to do. So let's just go ahead and try and do that. So we are going to do, in fact, we want this n squared. So we're going to copy that. We don't even have to type it. We can copy it. N squared for n in numbers. Okay. So we're going to loop for n in numbers, and we're going to take the square of it. And that's it. There's no if statements or anything, because we're not checking to see if it's above a certain amount or anything like that. And then again, we can print out squared numbers. So, and notice that this part here, this line was not needed, because this n squared, this append part, so this whole part, square numbers dot append, was all catered for over here. This is actually what is getting appended into the new list that we've created. So everything's done on one line. It's really nice and convenient. We like this very much. So let's just do a print of square numbers a second time, and we want to hopefully get the same looking list, and we do. So that is list comprehension part 2. So list comprehension in Python. Now, one extra piece is, let's say we wanted to omit numbers, and let's actually do this now. So our numbers will start to get big, 30, 50 and 100. Now, in both cases, we can run our loops, we can run our code, and this one iterates through, the top one iterates through the for loop, and this one does the list comprehension method. But this time we want to sort of like eliminate numbers over 1,000. So we don't want to have this append. So we would, inside of here, we would do something like if If n is less than 1000, then append, otherwise this doesn't get appended. And we can again see that this if statement here, we can manifest it to, we can literally just move it down. So this statement here, we can take it and put it straight into our list comprehension. Python understands that, it will do the filter for us quite conveniently. So it will look like effectively this. If I was to, let's just clear all of our contents as well, it will look like this. In fact, we could just literally take the same piece of code and paste it in here. And in both cases, oops, let's have a look. If n is less than 1000, let's have a look. Square, okay, we need to just, square numbers is empty. Oh yeah, we just wanted to check if n squared, we want the result. So if n squared is less than 1000, so here we'd have if n squared is less than 1000. So in both of them, we're literally copying this because we want to eliminate this number, these numbers that are greater than 1000. So we're doing the square of that here, and this whole if statement over here on line number 10 completely replicates inside of the list comprehension, and the same thing should be able to run. And we've done a filter there, so we've done this filter very nice. Now again, you could say, I don't know which one is easier to read. I'm actually going to say the list comprehension is still easier to read at this point. And again, if we wanted to, we could make it even easier to read by putting it on multiple lines if we wanted to. So we kind of like have a choice. When you've got really simple list comprehensions, it's just very convenient to have them on one line. If you've got more complicated ones, you might want to break them up on a couple more lines. But again, the same thing appears basically, which is that this pattern here of creating an empty list and then appending to a list has told us that we can essentially combine both of these items and put them all into one list comprehension. And we were able to do even an expression here. So we were able to have, like, n squared going in there. So in fact, let's just move that across if I can. I don't know if I can move, no, I'll probably move the whole lot. But we can have this n squared here going into, we could have this expression going into this number, this part here. So we didn't just have to have, the actual original item. And that's really it. That's the second part of list comprehension in Python, and a little bit more power. Yeah, it's all very good, and definitely something that we should be using when the situation arises. So that's really it.